neighbor algorithm. So this is also known as KNN algorithm. So this is a supervised classification algorithm where we are given n data points. We are given n data points whose classes are known, right? And we are also given a query point whose class is unknown. Right? And what we are asked? We are asked to which class this XQ will belong to, or classify this XQ to one of the known classes. Right? So let us see how this KNN solve this problem. So let's say we are given some data points belonging to these classes C1, C2, C3, and C4. So C1, these data points you can see they belong to C1 class. These data points belong to C2 class. Of course, this belong to C1 class. So majority of the data point here belong to C3 class, and the data points here belong to C4 class. Now what we are given is this is what we are given, and what we are asked. Let's say this is the data point XQ. This is the data point XQ, right? This is the data point XQ. The question is, to which class out of this 4 classes this XQ will belong to, right? So the class of this XQ is unknown. So we are asked to find the class of this XQ. That's the problem statement here. So how this KNN solve this problem? So what we do here is we find the k nearest neighbors of this data point. We find the k nearest neighbors of this data point. We find the nearest neighbors of this data point. How many nearest neighbors we find? We find k. So that k may take value from let's say 3, 4, 5, 6, 7, and so on. So this k can take any value. So normally we choose k as an odd number. So there is a reason for that, right? So I'll discuss the reason later. So but normally we choose this k as odd number. So we find the k nearest neighbor of this XQ data point, right? And how do we find the nearest neighbors? So one measure used to find the neighbors of this data point XQ is Euclidean distance. So what we do, we find the nearest point, or we find the data points with least Euclidean distance. So this is the procedure to find the k nearest neighbors. So find the Euclidean distance of all the data points from XQ. Let us say there are D1, D2 up to Dn data points. Find the Euclidean distance of all these data points from XQ, right? Then arrange these data points. So let's say these are the Euclidean distances of these data points from XQ. So then arrange these data points in the ascending order of their Euclidean distance. For example, let's say the Euclidean distance of this data point D1 is 1, this is 10, let's say this is 3, 7, so on and so forth. So arrange these data points according to, in ascending order according to the Euclidean distances. So after arranging this, pick the first k data points. K data points. For example, let's say we arrange these data points in the ascending order, and we got the first 3 data points as D1, D10, and D14. So these 3 data points will be the 3 nearest neighbors of this XQ. So we arrange the data points in ascending order and choose the first k. So here k is equal to 3, and let's say these 3 data points are D1, D2, D1, D10, and D14. So these are the 3 nearest neighbors of XQ. 3 nearest neighbors of XQ. Now after finding these 3 nearest neighbors, look at the classes of these 3 nearest neighbors. So what is the class of D1, what is the class of D10, and what is the class of D14? See, these are the 3 nearest neighbors of this XQ. Now look at the classes of these 3 data points, right? For example, if this is, let's say, D1, this is D10, and one more is D14. So this is, let's say, D14. So because we can see visually also, they are the 3 nearest neighbors. They are nearer to this XQ than other points. So this one, and this one. So look at the classes of these 3 data points. So you can see here D1 and D14 belongs to class C3. D1 and D14 belongs to class C3. These two, this one and this one, belong to class C3, and this belongs to class C4. That means out of 3 nearest neighbors, the majority of the data points, that is 2-bit data points, belong to class C3. So thus we can say that the class of XQ is also C3. That means we are taking the majority. What is the majority? So out of D1, D14 and D10, the majority of the data points belong to class C3. That's why the class of this XQ must be C3, right? So we take the majority vote sort of thing, right? So thus XQ belongs to class C3. So that is how this KNN works. It is simple. The algorithm is very simple. If let me summarize one more time. So here, so if what is KNN? In KNN, what we do? We find the k nearest neighbors of a data point XQ of XQ, and then simply we take majority vote. Right? So this XQ will belong to the class to which majority of the data points are belonging to. In our case, D1, D10 and D14, the majority of the data point here, 2 data points were belonging to class C3, and only one was belonging to class C4. So that's why we said here that XQ belongs to C3. So that is the KNN algorithm. So thanks for watching.